Hey everybody, and welcome to our introduction on electrochemistry. So this is going to be our next unit. It's actually our second to last unit. We've got electrochemistry and organic chemistry left. So let's talk a little bit about the ideas that we're going to get into for electrochemistry. Well, first we have to get through some sort of nuts and bolts ideas, and that's where oxidation numbers and balancing redox reactions are going to come into play. So a redox reaction is a reaction where one material gives up electrons and another material accepts electrons. So we have an electron donor and we have an electron acceptor, and we're going to talk about the language that's involved in that. And because these materials are exchanging electrons, they often end up changing the number of oxygen atoms involved in the different compounds. So a whole lot of rearranging of not just electrons, but also the atoms involved can occur in a oxidation reduction, or as the cool kids like to say, a redox reaction. And so balancing these particular reactions can be a little bit challenging. So after I show you the concept of oxidation number, which is a way that we use to track where the electrons are coming and going from, and it's somewhat similar to formal charge, if you remember that when you talked about evaluating Lewis dot structures. It's different, but it's similar to formal charge. So after we understand oxidation numbers, then we'll be able to get into learning how to balance these redox reactions. And I'll show you an algorithm that works every single time that'll get you the right answer every single time. You'll just have to make sure you're applying it correctly and consistently. Then we'll get into the actual chemistry, and the chemistry begins with galvanic cells. A galvanic cell is essentially a battery. It doesn't look like a battery yet. It kind of looks like a chemistry version of a battery. It's going to have beakers and solutions. But if you understand the basic concepts of a galvanic cell, then you're all set to understand the ideas of batteries. And so, as we get into the details of galvanic cells, we're going to need to know how much potential our battery or our galvanic cell is generating. And the potential is evaluated in cell potential, in volts. And so once we start evaluating the voltage of a galvanic cell, which tells us how much work the galvanic cell can do, then we're going to be getting into issues of thermodynamics and free energy. So there's a lot to talk about the connections between electrochemistry and free energy, and we'll get to those discussions. And then we'll actually get into the engineered package of batteries. So batteries like this little AAA battery I have. These guys are just well-engineered, well thought out, well-devised galvanic cells, because everything that goes for the chemistry galvanic cells that we'll take a look at will apply to these nicely packaged batteries. And what batteries do: batteries harness spontaneous chemistry, so chemistry that has a negative free energy change, and its work output comes in the form of a potential that we can harness. So we're going to take spontaneous chemistry, negative free energy chemistry, and we'll make batteries out of it. The flip side of that is sometimes we have chemistry that involves the exchange of electrons, that is redox chemistry, that we'd like to have happen, but it's non-spontaneous. We're going to ignore the phone bugging us in the background here. So we want to be able to get that non-spontaneous chemistry to happen. Well, what we do in that case is we actually sort of plug the chemistry into the wall, and we do what's called electrolysis. So electrolysis is using electricity to get non-spontaneous chemistry to occur. All right, so we'll go through some background stuff, some balancing stuff, some theoretical considerations for free energy, and then we'll show how we can take these theoretical ideas and make them real, and build batteries and do actual chemistry that's non-spontaneous using electricity through the routes of electrolysis. So there actually is quite a bit to cover in electrochemistry, but the good thing is nearly all of it is connected to ideas that we already have some background for. So when we do electrochemistry, we're really going to be applying many of the ideas you already know from junior chemistry class and sophomore chemistry class to the particular field of electrochemistry. Alright, so we'll start by talking a little bit about oxidation numbers and learning the algorithm to balance redox reactions. Until next time.